Okay. Good morning, everyone. Good afternoon to people on the East Coast. Yeah, so we have our what we call the VCO, a virtual consulting office. This is sponsored by our iGuide NSF-funded iGuide project. iGuide stands for the Institute of Geospatial Understanding through an Integrative Discovery Environment. And that's a mouthful, but basically what we do there is we are enabling sciences. And one of the things we do through the platform, through iGuide, is to build what we call as the iGuide platform. And that helps us to basically connect uh, resources and knowledges that have been produced by iGuide and make them accessible to the broader community. So that's kind of what the platform does in general. And today we'll have like a kind of a talk, hands-on demo kind of thing, led by um, Dr. Alex Michaels. Alex just got his PhD and is going to be actually starting his professorial career soon. So congratulations, Alex. So Alex is going to be walking us through what he has done and how he has used the iGuide platform, uh, essentially in terms of like the OpenStreetMap and network kind of graphs and how he did his analysis and things like that. So basically, um, how he used iGuide platform to enable his research. And the idea would be for this session to have people um, interrupt, ask questions. So this is kind of more of an informal session rather than a formal talk. So I just want to make sure that you are feel free to interrupt and ask questions and help. Um, yeah, help yourself and help us improve this the platform if you have any comments or suggestions as well. So that's what we have today. And without further ado, I will pass on the baton to Alex Michaels.
So the Jupyter platform is currently down for iGuide because I guess Jetstream is having some network issues. So
Yes. So maybe Alex, you can start off with your introduction part, and I think I just saw a message saying it was probably a DNS issue. Hopefully that could get resolved soon.
okay, yeah, we can try. Um, yeah, so today I'm going to be talking about exploring OpenStreetMap data on the iGuide platform. And as Anand said, I'm a PhD student here at UIUC working with iGuide. So for those unfamiliar, what is OpenStreetMap? It's, according to the About page, it's built by a community of mappers that contribute and maintain data about roads, trails, cafes, railway stations, and much more all over the world. It's essentially volunteer geographic information, VGI. So this is entirely a community-led open project. What kind of data is on OSM? It's a lot more than people think. So you can do some addresses. So for example, if you were to look up the Natural History Building or our address, 1301 West Green Street, Urbana, Illinois, 61801, you'd get that. You can look at boundaries. So city, state, time zone, region. This can be kind of nice because a lot of geocoding services will give you like a centroid where maybe you want like the boundary for a city. Transportation infrastructure. It's pretty hard actually to find good, complete data sets for this. And obviously, because it's VGI, it's not going to be perfect, but we have roads, footpaths, cycle paths, etc. Various amenities. So restaurants, offices, even like water fountains, all sorts of stuff, and even green space. So parks, trees, grass are all tagged on here. But the most important thing to remember when you're using OSM data is that it is VGI, as I said. It's not perfect. It might be a little bit messy. It's not going to be complete. And the completeness may vary depending on where you're looking. So for the United States, for example, it's pretty good, but maybe like rural areas, it's worse. And then for like developing countries, the coverage is much worse. So what can you do with this kind of data? So obviously a lot. But just to highlight a few examples, calculating travel time and simulating traffic are something that we within iGuide have done a lot of work with. So one example might be spatial accessibility. In this example, this image, this is driving times from Carl Hospital in Urbana using the OSM road network because it comes with speed limits as well. You could do evacuation modeling because you have the whole road network, including like directions, number of lanes, etc. Because you have such a variety of data, you can just also analyze all that kinds of data with a variety of techniques. So looking at amenities like restaurants, offices, you could look at green space. That's obviously important for health. And you could look at even waterways. So even some physical geography could come into it. It might not be the best data set for waterways, but there might be some interesting water features. For example, water fountains that aren't included in more traditional hydrological data sets. But again, remember, it's VGI. There's going to be some issues with this data. So the first thing I wanted to do with this kind of hands-on is just exploring OSM on the website. So if you go to openstreetmap.org, and I will put that in the chat, we can play around with the data a little bit to see what's there. So if sorry, go to openstreetmap.org. So this is the view from where I am. You can do the traditional zoom in, zoom out. You can get your location. There are a few default layers. So this is the standard. There's also two different cycling layers, transportation focused layer for example, these blue are bus stops, the red are bus routes. There's a more topography, and then there's a humanitarian layer. So all of these are described in more depth in the documentation. Everything with OSM is pretty well documented if you want to look more into it. But one of the nice things that you can do if we go back to that standard layer is if I'm interested in an area, for example, I don't know what the symbol means, you can right click and select query features, and it will show you all of the different kinds of data there. So I encourage you all to go into your web browser and do this yourself. And if you click on any of these features, for example, if I click on this fountain, well, this fountain doesn't have much data associated with it, but maybe if I click on this feature here, we go to this building, we have more information about like the building materials. Maybe if I click on a road, query features, it'll show me the footpath, the grass, the road. On the road, I have information on like cycleways along that road, what kind of road it is. So they just call it highway, but highway is not used in the same way that we think of it traditionally. There's primary, tertiary, etc. The number of lanes, the speed limit, the name, whether it's a one-way, surface. So a lot of this data is really interesting depending on the kind of research you're doing. For example, you might be looking at permeability of surfaces, and knowing this type of surface, that might not be a data set that you can easily find. Maybe it's something that you can do with like remote sensing, but even then, this could be an interesting tool to do data fusion with. So there's just a really interesting variety of data within OSM. But of course, if you're trying to work with this kind of stuff, you're not going to be, right click, query features, copy paste all this data into a spreadsheet, and then move to the next. So the main thing we wanted to talk about today was working with this OSM data, specifically in Python. And we wanted to talk about a variety of tools and software that can interact with this kind of data on the iGuide platform using our Jupyter Hub. So the four that we were going to focus on is Nominatum Web Service. So this is how their Places API works. For example, everything has an internal ID. Everything has different schema in here, the kinds of building, the building level, stuff like that. So this is how when I search like the natural history building, it knows where it is, what it's referring to. There's OSMNX. So this is a great tool for just generally retrieving OSM data. It was originally designed for network analysis. So NX refers to network X in Python, but it's a pretty general purpose tool nowadays for using OSM data. And then two more command line tools, but they work on the platform pretty minimally. You don't have to do a ton of work to get them working. OSM filter and osmosis. So these are powerful tools for filtering and analyzing larger data extracts from OSM if you don't want to do like individual queries. So just checking on.
Alex, they still have network issues. So this is Jetstream
Yeah, so I guess we could do this a
on the
couple
plan.
different ways. We could still do the hands-on and just use CyberJS X, or I could
Yeah.
just kind of walk through without the hands-on. Do you have a preference?
Let's go with like looking through the hands-on from the platform.io, and then when we launch to Jupyter X, we can switch to CyberJS, or you can walk through whichever works.
Okay. Yeah, so a bit of information on the platform. So the platform is actually still up. It's just the Jupyter Hub. So if you go to platform.iguide.io, this is the platform that we've been working on. The main slogan is Map, Connect, Discover. And the idea here is to get a bunch of different knowledge elements, is what we're calling them, but like maps, data sets, notebooks, publications, and all connected. So for example, if you click on this connect button here in the middle, it'll actually bring you to a large knowledge network showing you all the different data elements and how they're connected. The idea being that just because you have a data set doesn't really do much. It's more important if you have the data set with, for example, publications using the data set or notebooks showing you how that data set is analyzed or how it's used. So trying to bring all that information together, but then also trying to look for these non-obvious connections. We might be in different fields using the same data set, but using different techniques. So maybe there's things I can learn from you, but if I'm not reading your field's journal or looking at your research, I'll never know. But hopefully with this knowledge network, we can find these more interesting connections and work on these larger problems collaboratively. So when you want to access the platform, there is a login button in the top right. If you don't have an account already, that's fine. Just click login. It will register you for you. And it brings you to this login page. You want to choose your institution from this drop down. Sure, I did that. So if you are in a university, it's probably on here. If you don't see your institution here, click like Google or GitHub. But I go to the University of Illinois. And then the login is through your university or organization system. So you don't have to make a new, what's going on here? It looks like the login is also broken on platform. So you don't have to make a whole new account. You can just use those same credentials. We don't know your password. We don't have a password to leak. There's nothing like that. And then for the hands-on, I think we're going to move to CyberJS X. This is our previous iteration of the platform. So here's a link to the first notebook. If you don't have a profile here, it's the same process. So I'll log in just to walk through that again. You're going to click register with CI logon. You're going to scroll down and click continue to CI logon. And then you're going to select your organization or institution. And you're going to you just go through the login process. Oh, I'm already logged in, so it won't let me. So I'll just give everyone a minute to do that, to make an account real quick. And if there are questions at this point, feel free to ask. I know it's a little bit confusing because we're jumping around given the IT problems. So just to repeat, we're going to go to the link in the chat. You're going to register with CI logon. Don't fall for this trick. This is just an image. Scroll down and click continue to CI logon. And then once you have an account, we're going to be using that notebook that I put in the chat. So these are the same notebooks that I was planning on going through on the platform. And when you're on this page, you'll see it's a similar layout. There's a description, there's author information, but there's also kind of a preview of the notebook. So this isn't actually a notebook that you can run. This is just a preview to show you what it looks like. When everyone is ready, is there anyone who still needs more time to register to follow along? Doesn't sound like it. So when everyone's on this page ready, you can click this open with CyberJS X button. And what this does, if you look at this link down here, it's going to redirect to our GitHub, and it's going to do a git pull of the repository. So this is a notebook on GitHub, and it's going to automatically pull it to your directory. Just going to open our CyberJS X account. And I'm just going to click Python 3, select. So you should end up somewhere like this. And again, if you have issues along the way, feel free to stop me. Feel free to ask questions. All right, I will take silence as everything working out, but again, interrupt at any time. So now that we're here, I'm not sure how familiar everyone is with Jupyter, but basically this is a way to run snippets of Python code alongside descriptions and images. So here's just the title that I've written. And the focus of this notebook is kind of just warm everyone up, get people familiar with a bit of OSM&X, and then just kind of working through Jupyter. So this is just a description. We have to do anything with it. The next thing we want to do is import some packages. So contextually is for base maps. GeoPandas is for geo data frames. So this is how we're going to organize our geospatial data. Matplotlib is for plotting. And then OSM&X, as we talked about earlier, is for interacting with OSM. To run the cell, you can click this play button after you select it, and you'll know it's selected because it's a blue bar, or you can also hit Shift Enter. Now you'll see a bit of a scary deprecation warning. Well, you might see a bit of a scary deprecation warning. You can ignore that. It's just telling us that in future versions of GeoPandas, they're going to change some things around. And you'll see that it's done running when there's a number there. So if there's an asterisk, that means it's still running. When there's a number, it means it's been run. So now we're going to demonstrate the Nominatum API in OSM&X using the simple query. So I've just written Detroit, Michigan, USA. So this is a string, it's some text, and I'm assigning it to the variable query text. So we want to run that. And then we're going to use the OSM&X function geocode to GDF. So this is going to ask OSM&X, what is this place? And it's going to return a geodata frame. So when we run that, we're then printing out the geodata frame. This is what that looks like. You can kind of think of this as like an Excel sheet, but with geospatial data. So we have the actual polygon for Detroit. We also have the bounding box, the internal place ID. So this is an OSM only thing, but it might be useful if you're trying to like do deduplication. You can check, did these two queries return the same thing by comparing the place ID. The OSM type is relation, OSM ID, lat lon if you just want like a centroid or a single coordinate instead of the actual polygon. The class is a boundary, it's an administrative boundary, all of this information here. And then another nice thing in GeoPandas is the explore function. So when we run res.explore, that should create a interactive Folium map of the polygon. So there it is. So this is the boundary of for Detroit that is returned when we do that geocoding query. And you can play around with it. So this is just a very easy way to make sure, like, okay, we ended up in the Detroit area. We didn't get a polygon in like Siberia. That's a quick sanity check to make sure that we got what we're looking for. Now, we can do this with a variety of queries. So this is a city, a county, a state, a country, and then I also did a zip code. Turned out for the zip code, you had to put comma Urbana, which is where this is from. I tried putting like just the zip code or just USA. It didn't quite work. So there's some quirks to Nominatum that you'll run into as you're playing with it. But this is just a list of queries. And then this is just a for loop. So for each query queue in my list of queries, we're going to do the geocoding. We're going to save it into a geo data frame called PMP temp. We're then going to plot it. So this explore creates an interactive map. The plot will just create a static map. Then we're going to use the contextually package to add a base map to the axis using the coordinate reference system. And then we're just going to set a title so we know what each map is plotting. We can run that. This will take a minute just because it's doing 5 different plots. And then once we get those results, yep, here we go. So Chicago looks good. Once we get those results, this is supposed to be hands-on. You're not just watching me code. So I want everyone to try on their own. So try geocoding a place or places to examine the extent to which you can geocode. Try some weird stuff, maybe something that like your traditional geocoding service won't do. If you run into issues, you can always go to the OpenStreetMap site if you still have that open. So this link should bring you there. So for example, when I ran into issues with the 61801, which is a zip code, I put that in and see this says 61801 Urbana. That's where I got the idea to put Urbana. But for some reason, when I put in IL, maybe if I put in Illinois. So you can always use this as kind of like a test to see if I put it into the search, what does it recommend? And that might help you figure out what you need to put into this function. And then once you have a place, examine the data. So maybe show that geodata frame like we did earlier, or plot either an interactive plot or even just a static one. So the idea here is just to test it out, see that you can actually do what I've shown you, but also see if maybe it can do something unexpected. Maybe there's some data you've been looking for, or there's something your current geocoding service isn't doing for you. See if OSMNX can do it. See, I'll just give everyone a minute or two to play around with that. And again, if you have any questions anytime, feel free to pipe up or put it in the chat either way.
Maybe it's a good time to pause and see if people are having any issues. Is this completely going overhead, or like I know we have some technical issues with Jetstream today, which is causing like um having people to switch around a little bit. But again, like what Alex is explaining should be understandable and should run through the CyberJS link, X link that he shared. So people following
Yeah.
along, any questions, any challenges?
I think the silence is everyone working hard geocoding their queries. But again, as Anand said, we know that we're changing things up, and we know that not everyone has like experience with Jupyter. So feel free to ask even dumb questions, because you're not the only one wondering if you're
Yeah.
thinking about it.
Hey Alex, I had a question.
Yeah.
Have you used any other packages to like download these types of place-based information in Python?
Yeah, so we'll talk about that a little bit more in the third notebook if we have time. There are other ways to extract this kind of data. It's, yeah. So there are sites that have larger extracts. For example, you can get like the entire thing of Illinois, and you can even get like historical extracts. So if you want to go back to say 2018 and get the OSM data, but we'll get to that more in Notebook 3.
Yeah.
Yeah,
And
you don't necessarily have to like write out a list of things. The other nice thing that you can do is, for example, if you have a CSV of, say, zip codes or counties, you can create a list from that CSV instead of like writing it out manually, and then you can do this kind of loop to do it all. You don't have to manually write in every query.
yeah. And Alex, the notebook is also available on the iGuide platform, right? So there is the link which I posted on the chat. That's essentially the same notebook, and it also
It's
shows the
exactly the same. Yeah.
yeah, and it also shows kind of the related elements, related notebooks that you have there. So so hopefully we'll get or Jetstream will get that resolved soon, and we are able to log in. Oh, no, yeah. So that yeah, you have the
Yeah, so just to show that off, this is
yep.
the same notebook, and then on the iGuide platform, we have those related elements in addition to that connected element map. So I showed that briefly at the beginning. There's this network that's loading. In addition to this, every element has its own related elements network. So these are the 3 notebooks that we're looking at today. And then they're also listed here. And you can do all this yourself. So when you submit elements, you can edit it and add what elements are related to it. If there are any questions on that portion of things, even though we're not able to dive too deep into it, feel free to ask. All right, I'm going to assume then that everyone is doing good on this notebook. Everyone's following along, and we'll move to the next one. So again, I'm going to put the link in the chat. This one is Introduction to OSM Network Data. So for this one, instead of just looking up places, we're going to play a little bit more with road networks and specifically trying to run a simple analyses on these road networks. So again, you can click this open with CyberGSX, and it will automatically pull the notebook from GitHub for you. And as Anand was mentioning, this is also on the iGuide platform as soon as that's back up. So once you open that notebook, you should see this. I'll just give everyone a minute to get there. And these notebooks, as soon as you have them downloaded, will all be here under this file, so you can come back to it at any time. And of course, they're all still on both the iGuide platform and CyberGSX, so you can use them there as well. All right, so it sounds that the silence I'm going to assume means everyone is following along. So in this notebook, we're going to be using OSM network data, again, using OSMNX. And we're going to do a little bit of just travel time analysis. So the first thing, we're going to import a few packages, and then this is just setting a figure size variable just for consistent figures throughout. To run it, you click it and then click play, or again, click it and enter shift. And when the asterisk is there, it means it's not quite done. And when the number's there, it means it is done. So we just talked a little bit about what OSM is, but more information on OSMNX. So this is the README from GitHub. It's a Python package that lets you download geospatial data from OpenStreetMap to model, project, visualize, and analyze real-world street networks and other geospatial geometries. And this is due to Geoff Boeing, is I think how you say the last name. So great work. You can check out the paper here as well. And here are a few different methods for getting OSM data. So we'll play with just a couple of these, but just to give you an idea, you can graph from address. So geocoding, I can give it an address and give me the road network around it. Graph is just the math term for a network. from a bounding box, from a place. So for example, if I say, give me the road network of Detroit, it'll be able to do that. From a point, and then you can give it a buffer area around that point. And then from a polygon. So if you have a specific polygon, for example, you already have a zip code polygon, you can pass that and get specifically the road network within that. So the first one we'll play with is graph from place, and I have the documentation link here. So that could be useful if you run into issues when you're playing with this on your own. OSMNX has great documentation on Read the Docs that explain how to use the function, some of the pitfalls of using the function, what your parameters should look like. So a string, which is like text in quotes, a bool, so true or false, an integer. There's a lot of great docs on this webpage, and it's all one page. That hyperlink just specifically brings you that function. So we're going to use this graph from place. I'm going to ask for the University of Illinois Urbana-Champaign, and the network type I'm going to ask for is drive. Again, if we go back to that documentation, these are the options that it takes. So I can ask for all public. So for example, if I want to exclude private roads or private paths, bike for cycling, drive for cars, drive service. Actually not entirely sure what that one is. And then walk. So for example, if you're doing walkability research. And we can run this function, and that will save the graph in this variable UIUC underscore graph, and then we can plot it using the OSMNX plot graph function. So this is what we ended up with. Again, feel free to interrupt with questions at any time. Give everyone a second just to make sure all of theirs ran. And then it's a bit difficult to look at it in this image. So even, me from UIUC, I'm not quite sure that we're looking at the right thing. So they also have Grapholium, which will give you those interactive maps. So this is kind of like the version of Explorer we did in that last notebook. And now we can see, okay, it says Champaign and Urbana, so we're in the right area at least. And then, yeah, this is the correct. So for example, natural history buildings here, we've got all these roads. Looks right. And again, the documentation is great. There are other options here. So I can, for example, ask for different road types. I can ask it to simplify some of the networks. I can ask it to retain all. So right now it drops some of the network pieces that are disconnected. We can truncate by edge. So right now, if a piece of this network is sticking out of the boundary, it'll still keep it, but I can just cut it off exactly at the boundary if I want to using that truncate by edge. So there's a lot of great stuff in this package. So now give you a couple minutes to play with this on your own. Think of a place you want to make a graph from. Maybe it's your own college, your hometown. Again, if you're running into issues with that from place function, use the OSM site and type in maybe your university or whatever you're trying to query to see what comes up. Maybe you just need to change your query up a little bit. So as an example, if I go here and I type in UIUC, okay, now it corrects, but it didn't used to. It used to return a result of a building in China. So you never know when you might need to pop over and figure out what's going on. And then to add a new cell under here, you can select it and then hit B, or you can also, if you go, I think it's edit, add cell below. Where is it? Yeah, so maybe just select it and hit B. Believe. Not sure where they moved the cell below function. Or I guess you could also just use this plus. And that gives you the space to run your own query using graph from place. And then you can plot it using either of these functions just to get a little bit of experience with this. Maybe run into an issue and we can try to debug it live in case there are some pitfalls. And feel free to let me know if you run into bugs or just any kind of questions anytime.
Any questions here? This is wonderful way to extract graph. So, yeah, thanks, Alex.
Mhm.
Anyone have issues following along or have any questions for Alex?
All right, I'll take the silences. Everything's good. So the next thing we're going to look at is graph from address. So maybe you don't have like a unifying name like UIUC, and you just want to look for a specific address. Again, the documentation link is here. And we can look for example, natural history building. So that's where I am right now. So we go 1301. We can get the natural history building graph. And then we can plot it. So we end up something like this. So NHB is right here. I happen to know that, but if you're not from UIC, you might not. And again, we can do that folium graph, which will give us that nice. So you can get a nice base map using this plot graph, using that contextually function that or package that we used in the last notebook. But you can also just do the explore to get the interactive map, and then you can zoom in and see. Yep. So again, your turn. Feel free to insert a cell with this plus or by hitting B and try that out yourself. I'll just give everyone a minute to do that. And while you're doing that, again, remember, it's not just these two functions. I just singled these two out, but you have a variety of options. And then in the documentation, you can see there's a ton of options. But let's say I have a network. Now what do I do with it? I'm just have it in memory, but if you want to save it, there is a save GraphML function. So this will save it as the GraphML file format. You just give it the variable that holds your graph, and then a file path. So is going to save it to a file named nhpgraph.graphml. We run that. We can go back into the notebook. That's it. This one. And we'll see that file was just created seconds ago. So it's there. And then we can also load. So save load, pretty self-explanatory. We just put it in the file path and we plot it and we see we get the same thing back. And if you don't have a specific address or a place name, again, there's lots of options here, bounding boxes, points, and you can put a buffer there, polygons, etc. So we can get the data with this road network data, or again, you could do walking, you could do biking. How might we interact with the data besides just saving and loading it? Well, one nice function with OSMNX is that's compatible with GeoPandas. So this is kind of the default package for looking at geospatial data. We can do this graph to GDFS, and this will give us one geodata frame for our nodes. So these are like the intersections in our graph, and one for the edges. These are like the connections between those intersections, usually the road segments. So if we run that, we'll get both. And if we use the dot head function, this will just show us the first few rows of that geodata frame. And we can see we have the ID, XY coordinates, the number of streets, the highway variable. This isn't always filled in, but again, this will be like primary, tertiary, residential. And then the geometry. So we can also plot that in the same way that we were plotting the other geodata frames in the last notebook. And then we can repeat with the head, the edge. We can do the head and the plot. And then if you pulled your own data earlier, feel free to do that here. Or again, feel free to ask any questions. This will be just a bit of a stopping point. All right, seems like everyone's following along. So let's do a very simple analysis here. let's try to calculate the driving time from the natural history building to each other node in our network. So OSMNX has this great function called add edge speeds. So what this does is it looks at the edges that already have a speed limit. And then if some of the road segments don't have a speed limit, because that does happen, this is VGI, it's not perfect data, it will calculate an average based on the highway type. So for example, if I have primary roads and those average at 45 miles per hour, whereas residential's average at 30 miles per hour, it'll assign that correctly, assuming that the roads are tagged correctly. So we can do that. And then based on those edge speeds and the length of that segment, we can calculate the edge travel times, how long it will take to traverse that edge. Now, issue with this approach is that we're not considering the impedance that an intersection would cause. So, for example, a stop sign or a yield or a stop light. So that is a bit of an issue with this, but it's better than nothing, I suppose. And then if we have our NHB coordinates, which I've given you, we can use this great function called nearest nodes. And that will tell me the ID of the nearest node for my coordinates. So let's say you have a road network and you're trying to figure out distance from anything. You can get the coordinates, use this functionality to find where the nearest OSM node is on your road network. And then here, what I'm going to do is I'm going to plot the graph again, but I'm going to do it red if the node is equal to the nearest nodes that we identified, and else it's going to be white. So that's all I'm doing here. And we can just pass in that node color as node color. And you'll see this red, so the NHB is right here. This red node was lit up as the nearest OSM node, and everything else is in white. So I know I went a bit quick there. Again, feel free to interrupt with questions.
Maybe
Right, seems
question.
like people,
Yeah, sorry.
yeah, I was just gonna say, it seems like people are following along, but again, interrupt at any time. Even if I'm talking, put it in the chat, unmute, it's fine. This is supposed to be like an informal VCO.
Yeah. So maybe a question for all of you is like, are any of you using OSM kind of data for your own kind of work? And if so, yeah, like what do you think about this and how can we help you? And what do you use OSM data for maybe?
Or maybe what do you want to use OSM for?
Yeah. Thank you. Becky says the OSM data for evacuation modeling. That's a very good use. Any others? Yeah.
All right, well, maybe jumping back into the notebook, we have how long it takes to traverse each edge, and we know the node in our network that is NHB, or the nearest node to NHB. So we can use the network X package. And again, OSMNX is built to be compatible with it, to do something called single source Dijkstra's algorithm. Dijkstra's algorithm is just the shortest path, and we're going to use our graph. That particular node is going to be the single source, so we're calculating distance from that source to everywhere else. And we're going to use that travel time as our measure of how long it takes to go across each edge. So we can get the distances, we can print them, which just displays. So this just tells us for each ID, how long does it take to get there in seconds. But of course, looking at that's not super useful. So there's a set node attributes function. So we can use that distances and set it to the attribute called time to NHB. But again, you can, oh, we got another answer. OSM to identify water points in healthcare center. Interesting. I was talking about water points more as a hypothetical earlier. Yeah, I'd love to hear more about what you do with the water point. What do you mean by water points?
And feel free to
Maybe.
unmute and speak.
Yeah, feel free to unmute. This is supposed to be more of a chat than a lecture. While we're getting that reply, I'll keep going through the notebook. So we've set that attribute. We can then set the node colors. So up here, I did a pretty simple function to get the node colors, but we have more complex ones. For example, getting it by the attribute. So we're going to use that timed NHB as our attribute, and this red, yellow, blue is our color map. And then we can plot it by passing in the node colors. So we can see the further we get from NHB, generally the distance goes up. And because it's a pretty it's mostly a grid system. It's mostly concentric circles, but obviously on larger scales, and if we had a bigger variety of road types like highways, we would end up with slightly more complex patterns here. And then while we're waiting, if anyone has any other graphs that they've pulled, feel free to perform that calculation yourself just to make sure that you can do it. Maybe run into an issue and we can chat about it. Or if you have any other questions at this point. And then if you didn't pull a graph and you're just curious what else you can do, at the bottom here, we have some more notebooks that use OSM and X data. So again, a lot of our work is related to spatial accessibility with OSM, but you can also go to the notebooks discovery, and then there's more information on OSM and X down here as well. If you want to check out their examples repository, their GitHub, their paper, the blog post, anything like that. So I'll just give everyone a minute to either try their own example, ask questions, check out these links down here. And again, you can always ask in the chat. You can always unmute, whatever works best for you. Oh, that's really cool. Yeah, that's not a use case that I've heard of. I'll have to look into that. It's really interesting.
Yeah,
And then to answer Becky's question from earlier, because I'm not sure how much we're going to be able to dive into that last notebook, if you just Google something like OSM extracts, you can find sites like this, but this isn't the only one. And I'll put a link to this in the chat. So here you can find extracts for different regions, but maybe you don't want to use all of North America. If you click on the subregion, it'll keep going down a few layers. So maybe I just want Illinois, and it'll have the latest. Some of these will have older, but if you go back a few levels, I believe. Okay, so this isn't one that has historical, but I know there are quite a few extract sites that have a few years worth of data if you wanted to go back, but you can also use the OSM has a history, so they track changes across time, and you can use that to roll back to whenever you need. Yeah, so Becky asked in the chat, has anyone used Tiger geospatial data resources or other large coverage geospatial data like this, like Natural Earth? Yeah, it would be interesting to hear how that compares to this and maybe what you're hoping to get out of OSM that you can't get out of that. Like, I know I've heard OSM road data is a lot easier to work with than Tiger, but maybe that's changed. All right, doesn't sound like, oh, there we go. We only have, yeah, that's a good point. You only get Tiger data for the US, and OSM does technically have worldwide coverage, but I know that coverage varies quite a bit. Like the quality in certain countries is a lot higher than in others. So just be very careful when you're doing that for research purposes. And then we don't have time to really do a hands-on, but I'll very quickly just explain a bit about how you could use OSM filter and osmosis for like larger data extracts. So for this one, I'll just go through the image here. I won't actually, assuming it loads, there we go. So these are two command line tools that you can use for filtering like larger data sets. Again, if you don't want to do like individual queries or like a query by like say state. So I got this data from this extract. So this is one example of where you could get older data. Yeah. Yeah, I believe Anon, these slides are going to be, the video and the slides are going to be on the iGuide website after, right?
Yes, they will all be on
All
iGuide.
this will be there, and all these notebooks are also both on Cyberdisk X and on the iGuide platform. And the slides, there's not too much to it. My plan was mostly hands-on, besides these first couple slides. But yeah, so this is one example of a website that has data going back to, it seems, 2012. So that's where I pulled from here. And then I used osmosis to filter it. So just showing you, you can do this on both Cyberdisk X and the Guide platform. The installation isn't very difficult. It's like one cell. You don't really need to understand how this works. Oh yeah, NASA would have some interesting data. That's a great point. It would be interesting to compare that versus OSM, see where the pros and cons are. So yeah, I'll skip over these installs. Again, you just run those cells. You don't need to understand what they're doing quite yet, but just to show the basic functionality. If I use OSM filter, the OSM file, and then I say keep highway. Again, highway in OSM does not mean like what we traditionally think of as highways. Highways all drive roads, essentially. It's not like just highways in the American sense. And then the output file, you can similarly use osmosis to do even more in-depth filtration. So you can reject certain kinds of ways based on all the different tags. So here, for example, I don't want motor vehicle. I'm going to get rid of abandoned highways and corridors. I'm going to get rid of elevators because for some reason that is a highway tag. Raceways, because I'm assuming we're trying to get around and not just drive around a raceway. And then you can do all the same things we've talked about before using OSM NX to load data, using GeoPandas to interact with it as well, plotting it. But you can do some interesting filtration here. So this shows how to filter by arrowways. And again, the documentation here is great. There's documentation links here because OSM is very well documented. So here we're just going to look at airways in the area, and we can see there's two major airports, but also some helipads and other features. And then same thing with Explore to get an interactive map. Do it with offices. So maybe you're doing like some economics work. You're trying to understand density of office buildings. There's a whole variety of tags in OSM and a lot of great data. We can do, say, coffee shops in the area. So maybe we first filter by amenity, and we can get a whole variety of amenities. So looking at this list, we've got ATMs, benches, clinics, car washes, a whole variety. And then if we filter out by cafes and coffee shops, then we get this nice little plot of where you can get a cup of coffee in the Champaign-Urbana area. And if you're from Korea, you're seeing that correctly. We do have Cafe Bene. I know it is gone from South Korea. We have like, I think 2 in town. So be very jealous, or, just come here. So yeah, that was most of what I wanted to cover. I wanted to leave just a couple minutes for any additional questions, issues, maybe just talk about more about what you do with OSM. And we'll have all this online. And of course, you can always reach out to us as well. So yeah.
And I have the links for all 3 notebooks which Alex had for today in the chat as well. So any final questions or comments for Alex? Yeah, great presentation indeed, Alex. Thank you. So thank you all for attending today's VCO. We'll have another VCO in about a week's time. So look forward to seeing you there. That would focus on a different topic, but we run this constantly, and we'll like to get any questions or any feedbacks from you to make this process useful. Thank you, guys.
Yeah, and if you're at this one, you're definitely going to want, I think next week is Song Gao talking about spatial networks. So if you're interested in this, you're definitely going to be interested in that one.
Yep. Thank you all.